All right, so now we're going to be covering stem and leaf plots. So when looking, this is a unique kind of plot that it actually kind of separates numbers between their specific digits in terms of the tens digit and the ones digit. And what this does is this type of plot kind of helps show you what the frequency of the numbers are and help determine whether to use a mean or a median in determining a graph. Now, I'll go a bit more detail into that later, but I just wanted to give a basic summary of why we would use a stem and leaf plot. So when asking for a stem and leaf, what are stems and what are leaves? So first I'm going to tell you what the stems are. So the stems are any tens digit, at least in this case, for these numbers, it would be any tens digit. So if we would do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 0 through 9 here. And what this is basically telling us is that are there any numbers, or what it's asking is, are there any numbers with a tens digit of 0, 1, 2, etc. So let's look at the graph. So the first number we see is 21. And what this should actually tell us is that it has a stem of 2 and a leaf of 1. So we have a stem of 2 here. And if it has a leaf of 1, you actually just write 1 here. And since the first number we have here is 21, and that there is no tens or numbers with 0, like 1, 2, 3, 4, we can actually erase the stems of 0 and 1, because we just don't need them. So we start with 2. We have 2 and 1, which is 21. We also have a 23, so you could put a 3 here. Now, this does not mean that the leaf property is 13. What this is telling us is that there is a number of 21 and 23, not the weird 2, 13 thing. So we look at stem 3. Is there any numbers with a stem 3? There is. It's 30, because the tens digit of 30 is 3. And because of that, the ones digit is 0, so you put 0 here. Same thing with 4, 48. Ones digit is 48. In terms of 56, 56 is a unique case because there are 2 of them. You don't really need to do anything weird with them. You just put 2 6s. Oh, let me put 2 6s here. But there is also a 57, a 58, and 59. So you would also put 7, 8, and 9. Same thing again. Leaf does not mean it's 6,600 or 66,789. This is just how we would draw it. This is a bit ugly and can be confusing, so I'm actually going to put 5 here and 6 a little bit lower. Okay. 6, there's actually no unit with a tens digit of 6, so we can erase that. There's also not one of 8 or 9. So what we can do is just have the last one be 7, and we know it has a ones of 2. And this is how we would implement an array of numbers here into a stem and leaf plot. So this is important because what you have to ask yourself when you are graphing, what is the more appropriate method of determining the average of a graph? There is a term called either weight or bias. Basically, to give a fundamental summary, is that for a mean, means are best if the left side or the right side isn't skewed in any way. So what I mean by skewed is if we have a graph like this, we know that a lot of the numbers here are skewed to the right. And basically what this would show, or if even better, if we do something like this, what a mean would do here is it would not properly give us the average. What would actually give us a better average here is the median. And so when we have graphs like this, we want to determine whether or not, well, we want to create a graph like that and find out whether a mean or a median is appropriate. What some of the leaf plots can do, which is actually pretty cool, is that it can help us show what the graph would look like. Specifically, we could do something like this. And we could see, okay, the graph seems to be heavily weighted on these values, because there's a lot of 5s here, but even little 2s and 1s here. And then at that point, we can determine whether or not we use a median or median for graphing. But that's a little bit in the future. But for now, this is what stem and leaf plots are.